Alrighty guys, I figured this would be way easier for me to kind of walk you through this rather than just like shove it at you and be like, hey, good luck guys. So I'm going to try to be relatively quick, but like still thorough. So, okay, so lesson 6.3, we are looking at real world graphs in this lesson. And not only are we doing real world graphs, but we're looking specifically at the key features of those graphs and zoning in on reasonable domain and range. And basically, we are thinking about what kinds of domains and ranges make sense. So when we did our graphing investigation yesterday, we found some graphs that had like domains of all real numbers, or all real numbers except for 0. We found some ranges that could be less than or greater than a specific value depending on what the graph looked like. And then when we get into real world situations, though, we may have a function that models a particular scenario that would give a domain of all real values or all real numbers, but all real numbers wouldn't make sense. And that's kind of what this is looking at. Okay. So task 1, reasonable domain and range. In many real-world situations, not all values make sense for the domain and range. So again, keyword here is make sense. We're looking for things that make sense in these problems. There we go. For example, distance cannot be negative. You can't have a number of people be a decimal or a fraction. Stuff like that. So if I'm going by a number of people, I can only use whole numbers because you can't have like a half a person. A good video clip to watch, I may post it on Google Classroom. If any of you have ever watched the Andy Griffith Show, there's a whole debate about like Andy says something about there's a poor kid and every 3.5 boys or something, and poor little Opie's like, I've never seen a half a boy. And he's like, no, it's a ratio. Who's Horatio? It's hilarious. Go look it up. I may post it just because it's hilarious. But yeah. So anyway, so you can have a domain and range of a function, and but you can also have reasonable domain and range of the scenario that the function models. Okay. So if I look, question 1, easy peasy. What is the domain and range for the graph on the right? So if I look, you could use your foldable for something like this. It's not a card, so what I'm going to do just like domain first. So if I spread out and I only see the function, I can look and tell that there's arrowheads at the end, so it's going to continue, right? It's going to continue. It's going to touch everything on the right. It's going to touch everything on the left. It's eventually going to touch every single x value. So my x's are going to be all real numbers. Okay, so my domain is, for my x values, is all real numbers. And my range, my y values, same thing. If you were to open it up and look at which y values it touches, because it extends and it extends, it's going to touch everything on the positive side. It's going to touch everything on the negative side. There's not a y it's going to skip. So again, all real numbers. Okay. So we've done that before. We've been working with domain and range for a long time. That's just domain and range of this function. So now we get into some actual math, like some modeling. So here we have a taxi company charges a flat fee of $3, which is charged as soon as you get in the car, plus $2 for each mile traveled. We modeled that with this function, 3 plus 2x. Hey look, that's the same function for the graph on the right. So what are the reasonable domain and range? So x is the miles traveled. So what values make sense? So I kind of have a checklist that I go through when I do that. So let me grab a sheet of paper real quick and I'll go ahead and do a little checklist. So kind of a checklist I go through. First thing I always check, do whole numbers make sense? Okay, so I check my whole numbers first. Then I check fractions and decimals. Do fractions or decimals make sense? Then I check negatives. And then I think about specific values. Okay, so it's kind of a checklist. Certainly, like, you can get into more specific domain and range, but this is kind of a general checklist that helps with 90% of your problems. So, what you're going to do, what you want to do is you want to go through these, this little checklist. So, do whole numbers make sense? So, can I travel like whole numbers of miles? Well, yeah, like you can travel 1 mile, you can travel 2 miles, you can travel 3 miles. So, duh, whole numbers make sense. Okay, fractions and decimals. Can you travel 2.5 miles? Yep. Can I travel like 3 3/4 miles? Yep. There's not a fraction or decimal that's not going to make sense there. So like you can travel 2.0003 miles, and that makes sense. We probably won't measure it like that, but you can do it. So fractions and decimals make sense. Negatives. Can you travel -2 miles? So do not argue with me that, yeah, you can go backwards. Cab company is going to charge you for 2 miles whether he's driving forwards or backwards. Okay? 2 miles is 2 miles, forwards or backwards. You cannot travel negative miles. That doesn't make sense. And if you travel negative miles, then the cab company pays you. And that ain't going to happen. So mathematically, we have a domain of all real numbers, so that includes numbers that are negative. But realistically, we're not going to have negative miles, so negatives don't make sense in this situation. And then when I say specific values, we're not going to get too terribly into this. I mean, we'll touch on it some, we'll go over it some, but is there any, like, a specific number that doesn't make sense? Some of our functions will do 0 won't make sense. Some of our functions will do, you know, like a specific whole number wouldn't make sense in the scenario. But right here, like when we're talking about miles traveled, there's not a specific number that wouldn't make sense. The only thing that doesn't really make sense are negatives. So my domain for this, I can't have any negative numbers. I can have fractions, I can have decimals, I can have 0. I can travel 0 miles. I can just get in the car and then be like, you know, I've changed my mind. They're going to charge me $3 for inconveniencing them. So 0 makes sense. So my domain in this case, the only thing that doesn't make sense is negative numbers. So my domain for miles traveled, we can say that x is greater than or equal to 0. I can travel 0 miles. I can travel anything greater than 0 miles. I just can't travel negative miles. So this would be my domain. So we'll put negatives don't make sense here. Okay. All right, so what about for y? What about for cost? So again, we're going to kind of go through our checklist again. So do whole numbers make sense? Yeah, I can be charged $1 if I go half a mile. I could be charged, you know, $4 for something. Yeah, I can be charged a lot of numbers. Like whole numbers make sense. Do fractions make sense? Yeah, I can be charged $2.50. I can be charged $6.50. So that makes sense. Negatives, do negatives make sense? So negative values, again, if I have a negative, if I'm charged a negative amount, that means I'm paying the company. And that's not going to, I mean, if you find a taxi company, I'm sorry, that means the company is paying me. If you find a taxi company that will pay me to ride for them, let me know, and I will quit my job today and do that. No, I'm just kidding. Sorta. So negatives don't make sense here either. Now, this is a good one for specific values. If you think about it, if you just step in the car, they're going to charge you $3. So is there any way you're going to be charged less than $3? I mean, like, not calling the company at all, you wouldn't be charged any money. But, I mean, just but then that, again, that would be like traveling negative miles to get to that value. So like, even though zero doesn't make sense, or even though zero makes sense, like, yeah, I could just not call the company, but then you wouldn't have this function to deal with. So if you call the company, we're assuming we called the company. And if we called the company to come get us, they're charging us $3 whether they take us there or not. So the absolute least amount I can be charged is $3. So the absolute least amount is $3. So y is greater than or equal to $3. So again, that means, we said negatives don't make sense. Well, negatives aren't included in this. We said that fractions and decimals make sense. Like, I could be charged $3.50. That's fine. I could be charged whole numbers. I can charge exactly $3. I can be charged exactly $5 if I only travel 1 mile. So the rest of these make sense. The only thing that doesn't make sense is negatives. And in this case, it doesn't make sense to have anything less than $3. So like, even if I don't travel anywhere, if I call the company out, I get charged $3. Something else to think about is we did include zero. If I plug zero into my function, if I plug zero in for x, let's do that real quick. If I plug zero in for x, I do get $3. The only way for this to be less than 3 is if I plug in like a -1 or a -2, if I plug something less than 0 in, but those values aren't included in my domain. So another way to think of it is my reasonable domain range is only this portion of my line. It's nothing past this. After that, my function doesn't make sense for the taxi problem. Okay, so I hope that made reasonable domain and range make more sense. So here, negatives don't make sense. Anything less than $3 doesn't make sense. All right, I'm going to do number 3 with you guys, and then I'm going to see what you come up with 4 and 5, okay? So we'll do 3 together, and I'm going to let y'all do 4 and 5. So number 3, a banquet hall charges $15 per person plus a $100 setup fee. So X is the number of people, cost is given by this function. So X is the number of people. F of X is my total cost. So what's my reasonable domain range? So domain are my X values. So domain measures my X's. And for my X's here, I have, my X represents the number of people. So we can go through our checklist again if you want. But think about if I'm measuring the number of people. So this is, I like this function because it's making me think of my wedding way back when. And you get charged per person, like the caterer charges you per person. So you have a setup fee, and then it's so much money per person that's going to show up. That's why when you are adults and you go to weddings, always RSVP, because the bride and groom are paying for you to be there. So just, if you're not going to show up, let them know. And if you are going to show up, let them know. It's just, okay, I'm going to get off my manners soapbox for a minute, but just FYI. Okay. So I'm charging $15 per person. So if we think about it, can you have a half a boy, like a half a person? Again, I'm bringing it back to that Andy Griffith video. You can't have half a person. Please do not argue with me like, oh, well, but, that Vietnam War veteran doesn't have any legs, so he's only, no, he's a full person. He counts as a full person. Don't argue with me that somebody's like lost half of the feeling and they're still a whole person. You cannot count a half a person. A person is a person, no matter what. It's one person. So, people can only be counted in whole numbers. Okay? Can you have, when I say can you have negative people, can you have a negative number of people? No, you either have people there or you have 0 people, but you don't have negative people. Like, I'm not talking about negative Nancy. I'm talking about like a negative amount of people. You can't have a negative number of people. So my domain, I can only have positive whole numbers of people. So you could say that X is greater than or equal to 0 and must be a whole number. And actually, if you think about it, your whole numbers are 0, 1, 2, 3, so on and so forth. Whole numbers aren't negative anyway, and zeros including the whole numbers. So you could even, if you were super lazy, my curly brackets are not on point today. So there we go. So if you're super lazy, you could say x such that x is a whole number. That is this, saying the same thing, but kind of a little bit lazier and probably a little more concise. All right, so let's talk about range. Okay, so my range, again, since we can only plug in whole numbers, my range, my amount can only increase by 15s. Also, what's the lowest amount I'm going to pay? Well, if I host a wedding, they're going to charge me $100 to set up whether anybody shows up or not. Which, kind of sucks, but it is what it is. So my range is going to be over 100, or at least 100, and increases by multiples of 15. So, and again, this may not be the most scientific way to write this, but that's the best way I can think of. Okay, so I hope this was helpful. Please try 4 and 5 on your own. Just think about what makes sense in this problem. Do fractions make sense? Do whole numbers make sense? If that checklist is helpful, go through that little checklist. And I don't always write it out. I kind of do it mentally. But again, I've been doing this for like way longer than you guys ever will. So, tis what it is. Got any questions? Give me a holler. Email me. I was going to say call me, and I'm like, no, don't do that. Don't do that. I don't want to talk to y'all after school. I'm just kidding. Y'all email me if you have any questions. Or you can just hold on to your questions till Wednesday when I come back. That's probably the smartest idea. Y'all know me. This video is like way longer than I anticipated, but I hope it was helpful. If you need me, I'll be back on Wednesday. Y'all behave for the sub, and I hope y'all have a good evening.